Well, thanks to everyone who showed up. I appreciate it. Today, I wanted to do something slightly different. I promised a member of the RChain community that I would cover some of the performance data that Tomislav had collected in the AGM. And I was, again, so tired that I forgot to do it in the AGM. And so today I'm going to cover that data. It's before I put the graphs up on the screen, I want to remind everyone that the numbers that we see are under assumptions about the network that we're going to have to knock down. We're going to have to remove those assumptions in order to make sure that we can guarantee those numbers over a wider range of conditions. But the graphs are taken from existing code. It's not code we have to write. It's taken from existing code. So it's not as ideal in either direction, in the sense that it reflects what we should be able to achieve on a fairly regular basis. And we can probably do even better than the numbers that are shown, but this is about where we can be under decent conditions. I have to, in order to display the graphs, unless someone else has them, I have to switch to a different device. So give me just 1 minute in order to do that. One thing I do want to point out is that I think the best way to interpret these numbers is in terms of thousands of transactions per second per node. So it's an unusual measure. But the idea is, as you add a node and processor to the node, you'll get a certain bump in terms of the number of transactions. That's the here we go. Here's Jim coming in. That's the way to think about this. We should be able to turn that number into a cost per thousand transactions per second. But yeah, that's what's going on. All right, so I'm almost there. Tomislav has joined. So Tomislav can add some color to this. So hang on a second. All right, I'm gonna switch this device off. All right, so Tomislav, I was just saying to everyone that I had promised one of the community members that I would go over the results that you had, the performance results that you had gotten. And so and I forgot to do that in the AGM. I was just really tired yesterday. So I'm going to go over that here. Let's see.
Yeah, I didn't perform the latest test that I wanted to do. So because I created the Rust, Scala, and C# simple like Fibonacci number calculation, and I want to compare like parallelism on these nodes.
Yeah, absolutely. The one thing is that I've been thinking we should have a discussion about whether or not we could just write the Rolang execution. All right, well, I'll go ahead and put the data up on the screen just so that people can understand what's going on. I'll do a share screen, and here's the data I've got, and I think you've got better data. So again, I promised a member of the community that we'd talk about this in the AGM and didn't do it. But so essentially, this part of the graph is about what we can expect. The testing conditions were not ideal. So as Tomislav was just saying, the CPUs were saturated much sooner than Tomislav was anticipating, because he was running more threads than he initially anticipated. So if we had the number of threads tracking the number of CPUs, then this curve here is about what we'd see, which is, just as I said, it's about, roughly speaking, it's about 1,000 transactions per second per processor per node, which means if you add a processor and a node, so every time you add a processor, every node is configured with that many more processors, and you add at least one more node, then you're going to get an additional 1,000 transactions per second. That's the result of these numbers, and we can make this data available on GitHub. But Tomislav has run this for different JVMs, let's see, what else have you varied here?
Yeah, different JVMs. This is
basically just different JVMs. Yeah, that's right.
And in comparison, in comparison with 32 CPU DigitalOcean.
Yeah, right. That's right. That's right. Yeah.
This is where I saw that even with much more CPUs, they are very similar, because they are saturated immediately.
Yeah. So the reason the curve flattens out here is, what's really going on is we've overwhelmed we've saturated the number of actual physical threads with a lot more logical threads. And that, sort of, it's around this region here where it begins to flatten out. And the reason is because we've now got more logical threads than physical threads. And so what we need to work on is, basically lowering the cost of the number of physical threads. So some of that is software stuff that we can do, but some of that is also hardware. And this is something that I've been trying to emphasize now for at least a year, which is we've entered this phase where the physical architecture is exploding. So if you go and look at Elon Musk's AI Day, they are describing millions and millions of physical threads. So they have a hardware architecture that is supplying millions of physical threads, and they have to. If you sit in the Tesla, it is incredibly impressive, right? Because the image software, the image recognition software, is calling back home with the camera data from the car. And the thing is figuring out what the camera data means in terms of obstacles on the road, and then displaying that in real time back at the car. And so so in order to do that, yes, they've done a lot of tricks with machine learning, but they just have to have lots and lots of threads. And every hardware development is essentially going down this path where it's all about increasing the total number of physical threads. And RChain, as you can see from the beginning of this graph, where we do have the number of threads matching the physical hardware, RChain is set up to take advantage of that, right? So over the next 5 years, what we'll see is more and more hardware architecture. In fact, over the next 10 years, we'll see more and more hardware architectures coming out, delivering more and more physical threads. And we'll be at the point where we can just take advantage of that. We'll be able to hungrily consume all the physical threads. So that's basically the message that I've been trying to get across now for a very long time. For the last 20 years, I've been saying, literally since BizTalk was released in Microsoft, I have been saying, you have to build a concurrency model that will eat all the physical threads that the market is going to throw at you. And no one seems to have been paying attention to this, especially not the software architects of the blockchain, because they haven't provided a software architecture that that does that. But the graphs clearly show that, and Tomasov has better graphs which show go up to 30,000, I believe, where we see the knee happening.
Greg, if you can please open the third one on the right,
third page.
Third tab, yeah. No, the next one.
Next one, okay.
So here I lowered the number of par in the rolling term.
Yeah.
So and here is you can see how this linear scale, because in the beginning we are not using all of the CPUs, and that's the whole point, right?
Yeah, that's correct. Yeah, exactly. So that makes it even clearer. Yeah. So what we're seeing is somewhere about, this is the number of processors down here, or the number of threads?
Yes, number of threads.
Okay. All right. Yeah. So and you're running this on a 32 CPU, right?
128.
Oh, okay. All right. Yeah. But the line is pretty clearly linear.
Yeah. Until the point, or exactly.
Yeah.
100.
Yeah, exactly. So yeah, until about 100. Yeah, exactly. And then it levels out. Yeah. So yeah, right around here it starts to level out. Yeah. So that's what people should take away. Obviously we still have a ton of work to do. There's, but I think we can safely say that with this data, there's no question that RChain is the most scalable. There's not a single blockchain on the planet that offers this kind of performance characteristic. And this is our goal, right? Is to make this more and more apparent, more and more clear to all of the folks who are doing resource planning in terms of delivering their networks, right? So whenever an enterprise or a startup or a community is having to make some choices or plans about where to deploy their DApp, like our vote or social tokens or anything like that, when they're having to make choices about what software stack to pick, and then it's very clear they want to be able to get the transactions speed that matches that matches the hardware that they can throw at it. That's basically what it comes down to. And so I believe that it makes RChain hands down the choice. And then if you add on the behavioral types, where even if there is a competitor who can squeak by in some range, say down here or something, I mean, there's no competitor that's going to be a public chain that's decentralized. That has these properties. But if you let's say that there was some competitor if they don't also have the behavioral types to stave off, just all kinds of very serious issues in the smart contracts, then there'll be no reason to pick them. So this is the value prop, in hard numbers that I'm hoping the community can see we're demonstrating now. Any questions from folks?
Hey, Greg. Yes, I have a question.
Hmm.
I think it's been discussed in some dev meetings, but do you see a point where process orchestration will like take too much time and limit the number of threads?
Yeah, so I think that realistically we can use this technique out to about 1,000 processors. And then we'll have to take stock. Then we'll have to do some empirical discussion or empirical investigation and see what's what. But at least out to 1,000 processors, right? So that's 1,000, that's 1,000,000 transactions per second, which puts us in the TPCC benchmark data point, which I think that's plenty of headroom, right? These amps go to 11. Does that make sense?
Yep. Okay.
Yeah, that's what I've been planning for quite some time. It's about 1,000, and that's what if you go back and you look at the very first AGM, in my slides, I clearly said we want to get the network out to thousands of nodes per shard. That was the goal, and it's for that reason. It's because at about 1,000 in a given shard, I think you'll start to see it peter off. But again, there's lots of work to do between here and there, as everyone here knows. But that's kind of the limits that I'm seeing.
And we are fighting the sequential processors. So
that's correct. That's
this
exactly
is like
yeah. But I mean, I want to say that it's my intention in the next, maybe even before the end of the year, to get an M1 box and start doing some testing on M1s, so we can check that out.
Yeah, that'd be nice.
It'd be a lot of fun.
Yeah.
I don't know. I guess none of the data centers have the M1s yet, but I definitely think we need to start putting pressure on folks to support that offering as well. And it's to their advantage, because the power consumption on M1s is so amazing. And so if the data center starts adopting that RISC technology that does low power, then I think that will be a big win for everybody, right? It helps their energy costs. It helps the planet. These are things we need to be working on anyway. And to that end, I think I've been doing some thinking about how to continue engagement with GSI, just because it is always a win to work with Brian. And we got so much from talking to their engineers as well. I mean, it was one of the highlights of my week to have those meetings, because they're so smart. And I felt like like the collective RChain brain just got a couple of IQ points because we were having those discussions. I think that one of the things I can do for them is help them come up with an abstract machine characterization of their chip. And I think if we were to have that, I don't think it's very difficult. I've been mulling it over in my brain for a few weeks now, and I don't think it's very difficult to do an abstract machine characterization of their chip. And with that, we might see some other ways that we could map Rolang onto their chip. So I think I'm chatting with Brian this week. So I'm gonna toss that at him and see if they bite. And if they do, then we can look again at different ways to accelerate the Rolang execution. But that said, I'm wondering if we could, since the Rolang executor is already a module in our architecture, right? We there's an API wrapped around it. It's called from the overarching node. If we were to write the Rolang executor in Rust, just that piece, not the whole kit and caboodle, but just the Rolang executor, we might get a win. And so I want to start thinking, after we've, like block merge is moved on to mainnet, maybe we can start talking about some designs for how to do that. And maybe Jerry would be interested in joining us to do that.
Yeah. You mean not just the Merkle tree, right? You're thinking about the Rolang itself and
the Rolang, yeah, the Rolang interpreter, right? That thing, I think, because it's an object, in our design, and we call it. So if we were to, rewrite that object in Rust, and so all the calls are essentially foreign function calls off to Rust. That we might get a win crossing as long as we keep the API coarse enough. That should be a reasonable thing to do, and I think it does have the right characteristics to be relatively simply replaced.
Yeah.
Coolio, that's all I've got. Any other questions, comments?
Greg, do you think the bandwidth might be saturated before the physical threads get saturated? So, one of my concern is we do have to broadcast lots of data, the trace data for other nodes to replay the COM events, right? So do we have any idea how can we compress that piece of data so, we can potentially do more COM events?
So that's a very interesting question, but it's something we can measure. I would really welcome if someone wants to measure the actual bandwidth going between the nodes, just to do bare bones COM events. That would be worthwhile. The thing that's tricky about that, at least from my perspective, is that we can put anything at a name, right? You can put a blob, you can put a big chunk of a video at a name, and you can put an integer at a name. So we have to make some assumptions or parameterize this. The assumptions are, what kind of COM event are we talking about? If it's an integer, then it's this kind of bandwidth. If it's a data packet, then why is the data packet this size versus another size? Those are the kinds of things that would have to go into any measure like that.
I did some measurement for when we were discussing this with GSI. So we were interested, for example, what kind of bandwidth do we need? And now I'm looking at some of this data. 300,000 per seconds by what? Oh, 300,000 reads per second on the Merkle tree. That was, and so 10 transactions is about 1.5 megabyte uncompressed.
Right, right. So that's the other thing is we have to get a little bit more efficient about this is part of the reason why I wanted the Captain Crunch stuff put in, because that'll have an impact on bandwidth as well. Right. If I remember correctly, I haven't looked at this in several months, but I think they have a binary wire protocol that they provide automatically. Is that correct? Am I misremembering?
Are you talking about Captain Proto or
Captain Proto? Yeah, not Captain Crunch. Captain Proto. Yeah.
Yeah. I think that I think we can maybe squeeze a little. Yeah. But also I think we can gain much more by not even sending part of the event log that is unnecessary.
Yeah, that's true.
Right.
Yeah.
Because we only need the event log for the races. For all the other stuff, we can just reconstruct in replay, and this is what we don't have right now.
Oh yeah, that's correct. That's exactly right. That's all. Yeah, it's it can be algorithmically generated. Yeah.
Yeah.
It doesn't have to be sent across the wire. Yeah.
I mean, the first step is now with rebalances, merging of rebalances.
Yeah.
Now we have a code that is injected, and in evaluation of rolling, we are collecting this data for merging balances. So in the same way, we can collect whatever we need. So
yeah, that's correct. As long as it is a commutative monoid. Yeah. All right. Very good.
There's also flat buffers as an option to Captain Proto, and it's worth looking at either one. I mean, flat buffers may be a little bit more compatible with what we have, but when we get to that task, we can evaluate.
Okay. All right.
I have a question on this Cap'n Proto thing. Will it require third-party libraries like Node.js, RChain toolkit to also use this new protobuf or not?
Yes, if we change that, because this is how this is the format in which we are. Well, this is how we are storing rolling itself internally.
Yeah, it's
but
it's also what goes across the wire. So,
but we can separate these two things, because it's not completely necessary that we are using the same. So
yes, but that's a little tricky, right? Because then you'd have to write an adapter.
I was thinking between nodes when we are sending this inside the block, then this is completely required. But when users is connecting via HTTP, then we can hide this complexity. So I was thinking this.
I mean, you can certainly hide it. I mean, it's like it could be the same API call, right? But
yes.
But under the covers, it's using a different a different wire protocol or wire format. But I thought you were saying that we would keep the old wire format and then run an adapter on the server side, and that would be terrible. Because that'd be a lot of work for somebody. I
was just thinking how we can simplify for the users who don't really need to calculate the hash of the rolling term. So we can have like always a nice API that they can use, and under the hood we can.
Right. Yeah, exactly. So it potentially would impact some folks, but like probably Raphael's code would be impacted, but not terribly much.
Yeah.
Okay.
Yeah.
It would be a hard fork, right? I don't know.
Oh yeah, definitely.
It's definitely a hard fork because we're changing the format in which the rolling is stored.
Yeah, that's why we wanted to include that in one of the hard forks, maybe hard fork 3 or something like that, because so far we didn't have the resources to work on that.
Yeah, exactly. All right, folks, I'm gonna leave it there. Thank you so much. Good discussion. I'll make sure that Daryl prioritizes this Casper so that it will be out this week, so I can keep my promise to the community member. All right. Thanks to all. See you in Dev Stand Up in just a little while. Ciao, ciao.
Thanks.
Ciao.